welcome to Mental Perspectives, Season 2, Episode 2. Today we're talking to davexmachina, talking about AI. Very fitting to the name. So yeah, let's just start with the classic, who are you? And what can you tell us about yourself?
Oh shit. Okay, so davexmachina, right? My name is actually not davexmachina. Can you believe it, right?
Oh,
Can you believe it?
I did not expect that.
My God, it's a shock, right? My name is David Nunes, and I'm a researcher in computer science and AI in general, and like machine learning in particular. I'm right now finishing my PhD. I should be done with it already, but you know, things things happen.
Yeah.
And I work in language in particular. So I work in models for language and essentially how to make machines understand and kind of synthesize the kinds of things we do with language. That's about it. And I'm right now in London. Welcome to London, mate. We just moved here. And we also did some interesting work in like I'm using the things I usually do for my research in other areas. Like with my partner, we did this interesting work in using optimization techniques for mRNA production. So if you know vaccines and shit, like COVID related stuff,
Yeah.
you know, those things, we can just put those things in machines, and machines will tell you, oh, you do this, you know, it comes out better. It does part of the work for you. It's fantastic. Fantastic technology. But yeah, that's it. Like AI is a vast field, really. So it's, unless you have specific things you want to know, it's very AI can be. Everyone heard about like I don't know, generative art, for instance. It's very trendy right now.
Yeah.
Or for instance, chatbots. When everyone encounter like chatbots and stuff. Like the kinds of things that I do, you kind of notice them, but you don't know what they are. Like if you use Gmail, for instance, you've noticed that they added like a couple of things. It's just autocomplete emails for you. That's basically a language model. That's the kinds of things that I do. They study email data and then they just create this generative model capable of outputting text like you would, or like someone in that particular context would. And that's the kind of things you do. Autocomplete in your phones as well.
For starters, I think we need to go a bit into explaining what a language model is. Like, to my understanding, it's feeding a machine text. Yeah. And then it somehow sees what words are used like close to each other, and then it learns how to use words.
So here's the thing. Mostly all AI stuff, the field is very vast, but all AI stuff is representation and search and, you know, some task, usually. So what I mean is you have some goal you want to achieve, and you need to figure out a way to represent the things in that particular domain. For instance, in text, we need to find a way to represent text in such a way that a computer can deal with it.
Okay.
And then you have a task. Say, in language modeling in particular, the task is very simple. The task is simply, if you see a sequence of words, you want to know the sequence after that, right?
Okay. Yeah.
That's it. That's the task.
Like basically like one of these math riddles where you get like the numbers 1, 3, 5, 7, 9, and then what's the next number?
Exactly.
Okay.
Exactly. That's exactly like it. And so in theory, if you have enough data, imagine we were training like a model on the description of this podcast.
Yes.
For instance. In theory, if we see enough data about what a podcast looks like the transcripts and stuff, we could recreate it. And like we could create something new that, you know, based on what it has seen, we could create a podcast from scratch. So in theory, we wouldn't even need a Deevoz, right? We just call it Deevoz 2.0 and press run, and it does the podcast for you. You know, fantastic. But in practice, things are a bit more tricky than that. But the language model is just that. It's a model where we represent text. We input text in a certain way, and then it tries to predict a sequence of words that come after that.
That's very interesting. So basically, it's a bit like trying to predict the future.
Yeah, that's exactly what it is. But in such a way that usually you know the present because you feed data to the model, right?
Yeah, sure.
So you know what comes next. What these models, in particular, this subfield of AI called machine learning, what we focus on is trying to model things from the world. And what this model focuses on is, okay, I'm trying to model a sequence of text, and I've seen just a tiny bit that I have as input, and then you feed me what actually, I try to predict something, right?
Mm-hmm.
I try to predict what comes next. And then you feed me what actual came next.
Mm-hmm.
And so the model needs to correct itself and go backwards and go, oh, okay, so this was what I thought it was coming next. It's not quite what we've seen, so we correct that. So next time, if you ask me the same thing, if you ask the model the same thing, the model comes closer to reality. And you do that for, gigabytes of text sometimes and just huge models. And what you end up having is like this giant interpolator that memorizes many ways of producing these sequences that you can adapt to multiple tasks.
The funny thing about this is that there's actually a strong connection to the field of psychology here.
Yes.
Because the way we validate psychological tests is exactly like that. Like we basically do a statistical calculation to try to predict what the sample size should come out with.
Yeah, so, and actually, it's funny that you say that because AI itself has been founded from with people from psychology and cognitive science. So back then, there was no such a thing called AI. Even when I think the personal computer itself was an attempt at going forwards towards what we call today AI. Mm-hmm. But the personal computer, the thing they use every day, was an attempt to create an artificial mind, to put into a machine, into mechanical processes, the things we thought that were like reasoning and thought, like these mathematical abstractions. And like I think it was 56, if I'm not mistaken, a couple of nerds came together in the University of in Dartmouth. Yeah, a couple of nerds came together and they thought they would do this workshop, and they would solve the entire fucking thing. They thought we just sit here together for fucking summer and we will figure this out. We'll fucking build, just Giga Chat AI over here. Mm-hmm. And back then, it was just a bunch of, some computer scientists. Computer science was not even a big thing. Mm-hmm. It was, but it wasn't really. Not in the terms of, and not how it is today. Yeah. But like, you had computer scientists, you had like people from electronics engineering, you had like people from psychology, you had people from economics, because economists also deal a lot with models and things like that. Yeah. And cognitive science as well. There's people from something that was actually called cybernetics. You can't believe it. It's a cool name.
It's really cool name.
It had to do with like, you have a system, you have like a loop that the system produces things and has inputs, and you want to maintain the state of the system, like driving a ship. You want to keep the ship going into a certain direction. How do you automate that? That was called cybernetics, roughly speaking. So this bunch of nerds came together. And like, really, what I think AI is an attempt to run away from qualitative psychology.
Okay.
It was like, so do you know what behaviorism is?
Yes.
Right?
Well, I think we should explain it real quick. Yeah. So behaviorism is basically the idea that every human is just a recollection of behaviors that they have learned. So that was the initial idea. So the founder of that said, basically, give me any child and I'll make him a doctor or a plumber, like just by the way I teach him.
Yeah, exactly. And from a scientific point of view, more than that, you look at every system as a black box, basically. You don't care what goes on inside. Not really. You in terms of how you study the system, you have the system there. It's like a black box. Mm-hmm. You study the relationship between inputs and outputs. Mm-hmm. And then you look at how these relate, and you make inferences about what's going on inside, but based on this. Hello. You don't care about, neural processes or anything. Yeah. Not just about humans, like animals as well. Mm-hmm. And so what I think AI primarily was trying to do is, okay, if we put these things into algorithms, into computations, if you can transform this into some form of computation, we no longer have this qualitative mystery about how a mind works. because we designed something that produces these outputs, that takes inputs and produces outputs. And we know, and we can measure it. We can measure these things. So it in a way, it was it was a way to go away from that. Okay, we don't know what's going on. To we designed it. We actually designed it. So, and if it produces the same kind of things, it could be something similar inside our minds. It could be how minds work. Of course, it's not as simple as that, but that was the basic idea, right?
Yeah.
So psychology was very much involved in the creation of the field as we know it today.
Yeah.
And like philosophy of the mind and stuff like that. So it's curious that you say that it's very much like psychology. It is, because it goes to drink to many things, to statistics, to psychology, to cognitive science, to neuroscience, to these many things.
Certainly. So one of the ideas that people have when they hear AI is, I think, that 80s science fiction idea of having a computer that actually thinks like a human. So when they hear AI, they think there is a computer that actually understands things like a human would and can like have a conversation. I don't know, like Cortana in Halo or Elo in Mass Effect. How far away are we?
That's actually a shame. I tell you, that's a shame that people view it right like that, because, and this is a pet peeve of mine as well. Classically, there's two ways people have looked at this problem, and they call it different things, but like they call it strong AI or weak AI, which is an unfortunate name. The theories of how we look upon the field and decide where to go. Like the strong AI claims that, basically we want to imitate a brain and a human, a human being. So it claims that the system like is intelligent if it can imitate intelligence, like if it can perform at the level of a human.
Yeah.
And weak AI is more like we don't care about imitating a human. It's more about the tasks. And for instance, computers can do things that humans can't, right?
Yeah.
So would you call it that intelligence? Like we specifically look at tasks in weak AI and say, okay, the system is intelligent itself, but it's intelligent to do this sort of thing. And then there's my position, which is sort of weird, but in the community, because I think that humans are not the pinnacle of intelligence.
Okay.
Said it. I think that we're good enough. And I think that we're good enough because we're still here, right? But still, we're good enough. We have a specific set of abilities. But like all the animals, all the things in nature, you look at them and you're like, fuck me, I can't do that. Like chimps, for instance, there's this experiment with I think it was chimpanzees. Like people just put numbers in front of them and like the numbers quickly disappear and they click the fucking squares in order and they're like, they always have this perfect memory of where everything is, and you don't have that. We lost that along the way, along the evolutionary journey. We lost that because we don't need it.
Yeah.
Like they have this perfect visual memory because they need it. Like they need to face predators, right? And if like they look at a bunch of bushes, they quickly need to decide, oh, there's a predator. How many predators there are? Do I need to go up a tree? Do I need to fucking bolt it? They need to make the decision like that, right? And we don't need that. We came up with tools and shit. And one of the theories is that we traded that for language, like or enhanced social capabilities.
Yeah.
And so I think there's many things that we don't have, that we don't excel at, and there's many interesting things in nature, like hive behaviors, for instance, from bees, from ants, the way they like self-organize with very simple behaviors to achieve these marvelous tasks. Like, have you ever looked at a trail of ants just transporting food between, where they found the food and where their colony is? We actually have in AI. There's a field called there's a field dedicated to imitating these processes in nature and to figure out if you can extract algorithms from those that would help us to create intelligent systems. And we have algorithms based on ants. We call them ant colony optimization.
Okay.
For instance, yeah. And you can use the way ants track each other and create a path with pheromones and stuff to, for instance, in a space, in a labyrinth, or in a space with obstacles, create the shortest route between 2 points, which is harder than it looks if you do it the naive way. Like if you start at 1 point and if you only have vision, think bots in games, for instance. If you only have vision around you, how do you go about trying to figure out what's the best route, what's the shortest route between 2 points?
Yeah.
There's a million ways to do it, and the naive way is very computationally expensive. What we do is just one of the ways we can do it is just you create these artificial lands that just put artificial pheromones down in paths and just walk randomly, but they are attracted to the pheromones as well. So if you're closer to your objective, if you found the food, you start putting pheromones and going and backtracking and shit. And like ants quickly converge to the shortest route because that's just how the system works, right? And it's fantastic with simple rules like follow the pheromones nearby you, deposit the pheromone if you go further along the way. If you found food, holy shit, start putting pheromones down and just try to backtrack, following all the pheromones and stuff.
So basically like you had a bot, it waddles around a map, and then you make like a trail with pheromones, and you give the bot the simple instruction: if you find pheromone, follow it. Yeah. So at some point, like sooner or later, it'll end up on the trail that you want it to be without even telling him where to go.
Exactly. It's the best trail cool, as well.
Yeah.
As well. It's actually the best trail, the optimal trail. And that's fantastic. And we have a bunch of these examples throughout AI that we are not imitating humans. Sometimes we set out to try to imitate a system we observe in humans, but we come up with something different. And so I think that fundamentally, the goal of AI, to me, is not to imitate a human, because I think we're just good enough and we're like, we are what we are, right? We're fucking idiots. Nothing will beat natural stupidity. Not artificial intelligence, not anything else.
Okay.
But the goal of AI to me is to study intelligence as a process, as a thing that exists in nature, and as this fantastic ability of matter that self-organizes and fucking can act in a world and solve problems and adapt. That's, to me, AI is the study of that. Not just, but your question was, how far are we to imitate humans?
Yeah.
It depends. Very far, if you really want to create a kind of intelligence that, like, it's equivalent to a human.
Yeah, like in video games, like that's the comparison I make.
Yeah, but it's like, if you want to create an intelligence that's like akin to humans, you need to imitate a human fully. There's no such thing, again, this is philosophy, but there's no such thing as a body-mind dichotomy. Your body is your central nervous system, your entire thing, your stomach. You need to be hungry, you need to be mad, you need emotions, you need to touch the world in order to recreate the kinds of things, the kinds of mental processes and the kinds of everything that makes us human. You need to put that, if you really want to create like a proto-human or fucking AI capable of doing the exact same thing a human does, you need to do that. And we are far away from that, right?
Okay.
We barely understand half of it ourselves. But this is why I say it's not really a goal that we want to achieve, I don't think. It's a stupid goal. And it's like it distracts us from the real capabilities these systems can have. That said, how far are we from fooling other humans into thinking that these machines are humans? We're there already.
Yeah,
we are simple creatures. Like the Turing test, for instance.
Yeah.
Everyone has heard, not everyone, but the Turing test is very simple. Turing has this paper, gonna search for the Turing paper. What's the name of it? Computing Machinery and Intelligence. Yeah. That's it. From when it was debating, like building these Turing machines with this abstract mathematical concepts of computations and stuff. And he has this paper on what he thinks artificial intelligence is, and he proposes what he calls the Turing test, where imagine you have, in simple terms, imagine you have a terminal, a computer terminal, right now, in modern terms, and you're speaking in a chat box, right? And what you do, the Turing test is, on the other hand of the terminal, we either put humans or you put machines.
Yeah.
And you ask every participant in a study you would do if he thinks he was talking to a machine or a computer. And if he can't distinguish, statistically, if he can't distinguish, if there's no statistical difference in responses between people that think they're thinking to machines and they're wrong, and people that they're speaking with humans and they're wrong, those kinds of things. If you find no differences, you pass the Turing test. Your machine passes the Turing test, which means. But Turing didn't intend this to be a machine, a test for intelligence. Like, people often misinterpret this as, okay, if we pass the Turing test, we built a machine that is conscious and can think and can imitate a human. Yeah, that's not what's happening. Like, Turing didn't even intend it as that. What's happening is that we've reached the limits of what humans can detect, right? So we can't tell the difference. But that's on us, not on the machine, right? It's not that difficult. I mean, it's hard, but it's not that difficult to fool humans.
That's true.
And that's my point. If we think long term, like, if you want to imitate a human, we are long. We are like light years away from that, unless we start imitating humans. If we think fooling humans, we're already doing it. Think deep fakes. Think like even generative art. Like, people complain about it, that it's ripping off other people's art. And think chatbots, in some contexts, they can pass as humans pretty well. Or fake news generators even. We can tell the difference. We look at the blurb of the thing, we look at the title, we look at the summary, and we're like, okay, this is legit news, because we don't filter, But that's on us. It's really on us.
I guess. I want to talk about the concept of intelligence a bit, because it's really hard. Like, from a psychological view, it's really hard to really determine what is the intelligence. Like, we have that idea of IQ as sort of intelligence, but it's a very narrow view on it. Like, it's just
there's a million definitions, really, and even in AI we have a billion definitions, and it's like, to me, it's just the capability to, if you're talking intelligence in general, to adapt to environment. And like, not just it can be in the reactive way, where you don't have state. Reactive means you just have inputs and you react in outputs, and then you create these systems that collectively adapt to the environment, like a beehive, like an ant colony, things like that, like a school of fish, for instance.
Yeah.
Like a school of fish, a band of birds, those kinds of things. They are pretty much, like, in terms of collective behavior, reactive, but they solve these problems, these navigational problems, these avoid predators problems, these pathing problems. And in case of humans, you have language, right? So there's this additional layer that it seems complex, but really what we're doing is just, we're good enough. We're using tools to change the environment in such a way that we can keep surviving in it. And when you reach a certain point that it doesn't matter anymore, we start doing other shit. But and it depends on how we evolved, really.
But isn't that adapting? Like, the fact that we lost our basically our long-term memory, we adapted with creating, like, language and paper and writing shit down. And at some point we invented the internet. So isn't that like a very high sort of intelligence if you adapt to everything?
It is, because it is and it isn't. It's like, it's the next frontier, the fact that you can, first of all, you have culture, and you have culture in other animals as well. But with language, and particularly, not just language, the fact that we use tools to change the environment means we can preserve language, writing, right?
Exactly.
And so with writing, we don't just have culture like other animals, like culture that is preserved from individual to individual, like mouth to mouth. We used to, actually. We're not that different. For millions of years, we're like, there you go. Just mouth to mouth and teachings between, or tightly knit groups and tribes. But then, as soon as you put down things on paper, or papyrus, or whatever,
clay,
or clay, or whatever, you have like this cumulative effect, and you see this rapid fucking scale acceleration in what we do to the world, really, because we can learn from our mistakes, one would think. Despite if you look at the world right now, we would think that we don't learn very much from a certain point onwards. But we learn from our mistakes, we can record that, we can learn from the environment, understand how things work, and then just preserve that and pass that and distribute that. And that just means we found a way. We are a blob of matter that found a way to change the environment in such a way that further changes are easier to do.
Yeah.
And faster and efficient. It doesn't mean it's the pinnacle of evolution, though. It doesn't mean you could make the argument that that rapid adaptation to the world can fuck up your environment and lead to extinction. We don't know.
I mean, sure, it could.
And that's not very smart.
Well,
if you're putting it in those terms.
I mean, arguably, in the long run, it would not be very smart. But at the same time, there's nothing else, right? There's no next step on the ladder right now.
Yeah, it doesn't need to be. I mean, we're just matter changing the environment. That's it.
Yeah, right.
That's it. And that's why I said, to me, AI is the study of ways to do that, to adapt to environment. And you don't need to be a human to do that. You can do that better than a human, even. I'm not suggesting that we just give, autonomous agents the ability to start fucking walking around and fucking with things around us, because that's a stupid idea. Like ungovernable entities, autonomous entities just roaming around and, cutting trees and making fires and, rounding up humans and saying, prepare for probing. No, it's just that the study of the adaptation itself, it's, I think it's, that is the next frontier, really. And that does not need to imitate the ways we do it. Like, we have this very, it seems advanced, but fuck me, we're just apes throwing around things and writing down other things and reading like, oh, this is a good idea. This is, I don't know. It's advanced, but it's not that advanced. It is what it is, I guess, right?
I mean, I'm fully with you. I don't think humans in general are incredibly smart or incredibly dumb. They're okay. But still, I don't see anything else surpassing humans as a general.
I actually do. Look at even machine learning models, basic ones. Look at how inefficient we are at learning things. It takes us years to learn how to talk.
Yeah.
It takes us years to learn how to do anything. And it takes us years to learn how to draw. It takes us years to learn how to, play a music instrument, to play chess even.
Yeah, true.
I know chess is not the definition of intelligence, but many people have this notion that there's activities that are predicated on our special abilities as humans.
Yeah.
And this is actually a good example. Chess used to be one of those.
Yeah.
People are like, oh, computers, very smart. Can you play chess? And computers couldn't. At least not until Kasparov got his ass whooped by Deep Blue, which was just a big number crunching machine.
Yeah.
And people are like, okay, perhaps chess is not a good example. Perhaps we need another example. Let's see, Go. Go has this, it's impossible to have a machine to number crunch those odds and those all the possible positions of a Go board, for instance. And then
I don't know what Go is.
Oh, you don't know Go is? Go is that board game where you have just little stones, white or black stones, and you put down a stone. That's your turn on this. And
then you need to 4 in a row.
No. You need to conquer territory. There's a set of rules that is like a. It has been around from thousands of years. Yeah,
okay,
it was on our Nokias and stuff back then, right? You have the phones at Go as well, some of them. You need to conquer territory. The way you do it is just you isolate areas, you put your stones in front of other stones, and if they form an enclosed area, you capture that territory and you score points, things like that. Yeah. But in those kinds of games, the board keeps changing. It's not like chess where you don't have any more pieces, so you cannot play, or you get checkmate. No. You can go back and forth. You can keep changing the board and you can capture territory and put more stones and get more stones back. And so has millions and millions and millions of possible combinations. And so the way people did it was like, okay, so we take a neural network, which is, we can talk about that, but we take a model, just looks at the board and associates that board with a specific score, right? And we can even disentangle the board into multiple possible steps we can take or places we can put stones in. And like we look at those, we don't look at all of them. We just look at a couple of steps ahead, right? And we score them. We have this, but we don't do it. Humans are not the ones doing it. The model itself has this learnable function that looks at the board, gives it a score. It might be a wrong score, right? It might be a not very good score, but you find out as you play and you get hammered, like the model gets hammered, like, okay, this was not a very good score function, right? I need to change how I score this board. And you keep playing these games. And the way we did it was like, instead of playing against people, we take a model, we train it in a bunch of games that we have records of, like other pro players around the world, like grandmasters that go. We train them in these games. And then we take the exact same model, we copy it, and we put the models playing against each other. And so it can only improve, because it's like, to win, you need to be better than you need to be scoring better than the other model, and you have this competition between models. And certainly you arrive at this model that was capable of beating the Go grandmaster, like the world champion, a couple of years ago. DeepMind did that, showed that it was possible. And so the guy was like, okay, you made Go not fun for me anymore, because suddenly it's not a creative process. I don't feel like, the guy was like, suddenly I don't feel like this is that special because a machine can do it. And like, we keep moving the goalpost though. It's like, what about this? What about this? And we keep finding that these tasks we think that are very human-like are actually solvable. But here's my point, is that there's certain tasks that it doesn't matter if you automate them, because why we value those tasks because they're humans making it. And art is one of them, and music is another. Like, you could say, okay, I have a model that produces beautiful art. Sure. But who gives a shit? How was the life of that algorithm been like? Has it been through a war? Has that algorithm experienced hardship in life? Does it have something to talk about? It could. You could make an algorithm that goes through hardships and like experiences things, but the things he would express would not be inherently human. You can view them as such, but like, we have interests in artists not just because of their art, but because of their life and what they have to say. Same with musicians.
Yeah,
it's not just, unless we're talking about pop music and stuff like that, you can just crank a lever and there's a million songs like them, right? And you just put someone half naked dancing, like doing TikTok dances in front of it, and you have an instant success. But I'm not talking about that. I'm talking about.
I love the subtle shitting on pop music.
No, it's fine. It's fine. Actually, there's pop music that is really good.
Yeah,
I'm just shitting on the industry itself.
Yeah, fair. I get it. Yeah. It's like, pop music oftentimes seems very calculated, and arguably you could easily AI that.
And it is. And you already do, actually. You have people that just calculate, like, what does well in the industry. And, okay, this fucking 5 or 6 chords does very well in here. This kind of sound does very well. So we just crank a bunch of artists, like, doing this kind of shit, and it works. But my point is, we don't value... That's entertainment. That's not art.
Yeah.
Right? That's different.
Yeah, true. Agreed.
And like, we don't value certain things just because of the outcomes. We value because it's a way for people to communicate between. We value the other human on the other side.
Yeah.
And that cannot be replaced, because unless you build a human, unless you build a copy of a human that we care about and like has a relationship with us, like the film Her, in a sense. But still, unless you do that, you won't come up with the same value we attribute to those things. So,
yeah, true. I remember a couple of years ago in one of the big tournaments in Dota, they actually had like some researchers build an AI or build like a model to beat the pro players in mid lane. And it took a while till they finally managed to get one together that was able to beat pro players. And then they made it basically available for everyone so they could play against it and see how they do. And arguably, I mean, Dota is also like it's a very complex game, but you can just be perfect in your mechanics, and that will change a lot.
Exactly. But I think the challenges it is in these particular games, if you're talking about games, is like it's not so much it's the nature of the task and what capabilities you need to solve that task that makes it an interesting problem from the point of view of AI engineers and stuff like that. We want to solve those problems because there's particular aspects that we need to deal with. In chess, it was the fact that it was expensive to compute, but like we needed to search the search space in an efficient way to beat the other player. In Go, it was impossible to search the search space, so we needed other ways to tackle that. We need to find ways to create a function that looks at the board and immediately knows, like, is this a good board? And like you just search the space for a couple of boards and you're like, okay, this is the better path because I know that I've seen other examples of this path. In games like Dota, it's like it's continuous input. So it's not discrete. It's not something you put a stone there and there's a state. It's like something that's ongoing. And so the challenge there is, what set of inputs do I give my model to control this thing on a screen in such a way that beats the other players? And that's more complex, right? We keep scaling up the complexity level. We did it with StarCraft as well, by the way. It's a common benchmark in AI for games kind of thing, StarCraft.
Yeah.
Because it's also continuous domain and things like that.
Yeah, that makes sense. All right.
But yeah, they keep moving the goalpost, but it's, these specific tasks we can probably always get an answer to.
I guess before we get to the questions, a very interesting question to me would be, like, where do you see the main applications of AI? Like, where does it need to be? Like, where does it really give us an edge?
Oh my God, there's been so much. So I watched this economist had a really interesting take on it, which was multiple of them, which was like AI like created a new type of commodity, which we didn't have before, which is prediction. We could automate all these kinds of products in the past, but we never had predictions as a commodity, as something we can integrate in things. And so this is really a new frontier for the markets themselves. And with prediction in mind, you have a lot of applications like, I don't know, like weather, studying the weather, the patterns of weather, environment can give you an edge there. You can model these very complex things, very complex systems in a way that humans can't, and in a way that simplistic mathematical models can't. I'll give you another example, COVID. I think most people working in epidemiology kind of use these simple models to kind of paint a picture of what's going on, but they all fail because the thing is, the way they have this very simplistic way of looking at modeling these epidemics, which in a larger scale kind of works sometimes, but in a more local perspective, if you will, you need to take into account that people behave differently for different reasons, and it's not always rational reasons, right? And so AI, for instance, there's this thing called agent-based modeling, which is something I used to work in a couple of years ago, where you do social simulations, and you look at society, you take human behavior and try to encode it in these abstract models of how people would behave, and you model these agents to kind of mimic these macro ways in which people behave generally, and then you look back at the system, you let these agents interact with each other, and you look at it and you're like, okay, the system converges to this state, and you can ask questions. For instance, what if people behave this way? You can do simulations, and you can do these models that act in accordance to your question, and you can look at these complex systems, unravel, and see, okay, so if people behave this way, this would happen. with the system. That's another way we could look at it. So this kind of complex system modeling is something we can do with simplistic approaches, mathematical approaches we have right now.
Mm-hmm.
And it's something that has been underutilized during COVID, unfortunately, because we're slow to respond to something like this.
Yeah.
Another thing, I mean, you've seen with language models and stuff, people kind of automate replies in emails and stuff like that. It can help you better. It can help you to write, for instance, better or worse or differently.
Okay.
This is something I noticed from, writing, that sometimes you look for different ways to say the same thing.
Yeah.
And you kind of look for vocabulary and stuff, right?
Especially in scientific writing, yeah.
Yeah. And not just, even creative writing.
Yeah,
sometimes
sure.
you want to find different ways to express what you want to express.
Mm-hmm.
And it's difficult because you have this vocabulary and you're stuck with it, and you try to deviate from it, and it's not easy. Language models can help you with that. Another way, because they can tap into different domains and different ways of people talking differently and give you, suggestions that you can take, and like, okay, perhaps I could say this way.
Yeah.
Speech recognition is a big one.
Yeah.
Because we usually use keyboards and mouses and fucking remotes, and it would be great if we could just get home and say, turn on the lights and fucking put on some. You have that with Google to some extent, and Siri and those assistants, but they're very rudimentary still.
Yeah.
I guess it's a different way to interact with these computational systems. And then you have the elephant in the room, which everyone is complaining about, which is art.
Yeah.
There is being, like, they say they want to bring art to the masses. I don't think I think it's fine if we're honest about what the models are doing, but what they're doing is they're using models to memorize kinds of art styles and what artists do, and then to output that.
Mm-hmm.
And the models don't deviate from that. They say, oh no, but the model creates something new because it's the algorithm. It absorbs all sorts of things and then it creates something different. It does not.
Okay.
It creates like a variation of what it has seen. And the question is, are we using these things to wash away licenses and discard artists that have done the work that we trained the models on, but then we don't need the artists anymore because the model can just crank 1,000 of drawings? They say, oh no, but you can just generate a rough drawing and then an artist can correct it.
That's not art anymore.
Enough.
Yeah.
That's fair enough, but it's also bullshit. I think if it's used properly to create assets from, say, public domain art and like art from artists that have given their consent and gained something in return to have their art used in these systems, that's fine if you use it responsibly. It's not fine to just rip off artists and say, oh no, but the system is creating something new. It's creative. And we have a lot of these words that kind of create this fuzzy barrier between what humans do and what machines do. Like, oh, it's creative. It's creating something new. It's not. If you know how the model works, you know that it's not, and it's bullshit. But people say, oh, but there's no way to stop this. There is. It's just don't rip off artists. And
I mean, but that's a personal level, isn't it? Like, you can personally decide to not rip off artists.
It is, but we need to. There's a way to also use these systems to look at a piece of art and essentially creating a reverse search engine to decide if this piece of art has been ripped off for someone or not. Mm-hmm. And we could do that, for instance. But it's like, it's an application. We can create something visually appealing. We can create images, which we couldn't before. But it has its dangers as well. And I think it's very empowering for some of these things, but we need to be aware of the damages we're doing. Same with music, although music has been a bit harder to do. Sound is notoriously harder to deal with algorithms and stuff, because sound is very complex, more complex than it seems. But yeah, another frontier of application is taking things that usually humans were the only ones capable of doing and just, modeling those things and offering tools that help us create those things quicker. But we need to look at it as not as a commodity, but as a tool and a responsible use of a tool. Finally, we can use it in all kinds of fields. I'm just talking about things we usually use them in. All these applications are like people in AI trying to make consumer products, which is a shame because there's a lot of scientific fields that could gain so much from AI, like the work of privilege I was talking about. Like you can use these things to optimize lab work, for instance.
Mm-hmm.
Like suppose you're trying to create a new vaccine and you're trying to have these reagents. You need to optimize these things. You can like connect robots to these algorithms that we currently use to just optimize our own things from machine learning. We can connect these algorithms to an actual lab and let them run and create these formulas more efficiently. We've seen that with protein folding, for instance. People have applied that to just try to predict things that are likely to occur in nature instead of just looking for them and then looking for them. Like that's what people in biochemistry and stuff are doing as well. And physics, there's models of the famous model of the black hole that was, reconstructed from just fucking terabytes of information about this thing and created an image that represents the black hole. And there's a lot of applications there. I mean, that's why I say imagination is really the limit. But can we get over ourselves and imagine things beyond our capabilities, though? I mean,
I could also see like a big use in like medical treatments.
Oh no! Oh, come on! Yes and no. I agree with you. Yeah. There's uses like for diagnostics.
Yeah, exactly.
But with a big but.
Okay.
With a big but, which is the fact that people are using this particular field as a way to say, oh, we use AI to do automatic diagnostics and stuff. And usually it's bullshit because it's more complicated than that. And it's not just looking at an image and going, oh, there's a fucking cancer there. It's not just that. You can use models for that. That's fine if you train them properly, but you need to train them properly. Yeah. If you have an expert on the other side just getting the results and going, yeah, the model is actually right. There's actually something here. So you can save some time, but not people. You can save some time there, but diagnostics are complex and have consequences. And so you cannot just say, oh, we automate them. It's like the computer says you have cancer, you have cancer. That's a problematic area. It's good as a tool, but so many people have been using this to hype their own technology and their own startup and their own thing when they don't have the proper tools implemented. They don't have the proper data. There's a privacy issue, madness around this fucking things because you're training on data that is personal. And, these companies sometimes don't care about that. They just make deals with these hospitals and stuff, and they get this data from all these people and just crank it in a model that is poorly designed, poorly optimized, and fucking start saying, oh, we do automatic diagnosis. You really don't yet.
Like
these models are...
My idea kind of came from the point that with a lot of like very rare diseases, you need to have like a doc that has heard of that before and thinks of it while research, like while treating you, basically, to even have a chance to give you the right treatment to what you have if it's rare.
Oh, so I see.
I was thinking like an AI would be able to be aware of every rare option out there because they don't have that human memory issue.
Yeah, I agree with you, and that has been done to an extent.
Okay.
But there's another issue, which is physicians are very reluctant into using these tools. They don't want to. They really don't.
Yeah.
Like in the past couple of 2 decades ago, I would say, these things emerged called recommendation systems, right? And it was just basically AI people trying to create these databases of like symptoms and stuff, even in health and diagnostics.
Yeah.
And then, you would input the symptoms of the patient, and it would come up with different possible diagnoses for these things based on the literature. And I think you can do that nowadays better than you could a couple of decades ago.
Yeah.
But again, if it's to review literature, it needs to be well done, and you need to make sure that these tools are integrated with the people that practice medicine and not replace them. Because many of the things, I agree with you, many of the applications sound good in practice, but what ends up happening is that people want to replace the people doing that irresponsibly. Yeah. They want to just put half-assed models doing things that they're not very good at doing yet. They claim they are because they are a fucking startup and they need the money.
Yeah.
So, but they want to put these things doing half-assed jobs and then claiming that, oh no, we can replace people doing diagnosis, and they really can't.
I mean, I'm not coming from an ecological point here. I'm not trying to replace anyone. I was just thinking that would be a good appliance if done well.
It is, and actually to review literature in general, not just in medicine, but there's so much shit out there. So that's just the term. There's so much, especially nowadays, and especially I see that in my field in AI. Just there's so much shit published every single day that you cannot possibly go through all of it and make informed decisions about what's good knowledge, what's not, what's shit, what's not. And so yes, we could create models that help us in this, with this sifting through information and giving us better like search engines, if you will.
Actually, that I did not even think about that. Like when I was thinking back, when I was researching, the amount of horrible, bad studies I've read, only to get like real angry afterwards and like screaming and running around in my room and like, I don't know, ranting to my girlfriend of how terrible that study is. It's just mental. So actually having a way to filter out horrible publications would be amazing.
But it's super hard though, because that's the difficult part.
Yeah.
I agree with you, but I mean, sometimes trained scientists can't even do that nowadays.
Yeah.
So it's really hard to create a data set that is curated with what we consider good science, and then figuring out why is this good science, and then putting a machine doing that. It's still it's a hard task because it takes more than the actual data. Like we still haven't encoded into something that is actionable this knowledge about what is a good scientific process, what's a good study. I mean, define me a good study, define me the kinds of tools that are appropriate for different things. We haven't put that into computation models yet.
Well, I guess I could start defining that, but that's also getting very technical. Like if I'm thinking back about the bad studies that I've read, they failed at some of the most obvious points. Like, for example,
that's true. Sample size and
exactly they had like a sample size of 10 with people that had like nothing in common.
They're all students. They're all students there.
Yeah, it's and then they make like they give a result about how gaming makes everyone aggressive based on 10 people that have never seen a PC before, and then giving them Call of Duty while they are incredibly frustrated while they don't know what they're doing. So yeah.
You study, I ask my family, but you're not wrong. There's people that's like, I called a couple of jabronis to the lab, and they went, oh yeah, this is totally how I do things.
Half the bachelor theses are exactly that. You call your jabronis and your family, and then you have your mom fill it out like 3 times because you lack 2 people, and then you see there's like 3 answers missing, and you just like sit in your fucking statistics program and type in the numbers yourself because you cannot be asked to find another person to do your fucking study. So sadly, that is reality of psychological studies, and I assume it's the same in every other field.
It's the same in every single field, and it's like even if you have enough people for a study, if you have your sample is well distributed and you have representative like groups and stuff, then you come to the statistical part of the thing. Where you need to sit down, look at the data, and make assessments of what's the truth here.
Yeah,
and people don't have the knowledge to do that. It's insane. Like trained scientists don't have the statistical tools, don't know what they're doing. They just go to a program, they insert the data, they press a button, and it says, oh, this is different. There's a statistical significance of this difference. It's above a certain random threshold, so you found truth here. And it's just not My God.
I feel you so much on that one. And then like half these people don't even know how to do that with a fucking program.
Yeah.
So yeah, that's where I came in then, because I didn't know how to do it. So I made like 4 or 5 statistical bachelor theses at that point.
Oh yeah. But in AI, you see another problem, which is in the field, which is we're approaching a point where, like, big companies, especially the Googles and the Amazons, the Facebooks of this life, right?
Yeah.
They pretty much control the narrative on what's good science right now in machine learning and AI, which is insane.
Yeah.
Like you have like companies coming up and saying, "Oh, we have found a revolutionary way of doing this thing," and people in the field are like, "What the fuck? We've been doing this for 20 years, and these guys are getting credit for it." But the result is that, like, every young scientist coming into wanting to study AI and machine learning and these kind of things, look at these fantastical stories from Google, from Facebook, and I want to do that, and so everyone is doing the fucking same. And what you end up having is this field that is stuck on, especially machine learning. You have this task, and now if you want to be successful, you need to succeed at this task. And what this task is we have this data set, and like language modeling, for instance. This data set, your model is good if you can present it with a set of texts, and if you can predict the sequences in those texts in those texts without ever seeing them.
Yeah.
That particular data set. And so people come up with all these convoluted architectures to just improve and go like, okay, my model is 1% better than yours. And people, oh, yeah, publish it. You're published. 1% better, published. You made progress in the task.
Yeah.
And it's all fine. But the problem is people would go and say, okay, I added this to my model, or my model does this differently, and this results in this improvement.
Yeah.
And sometimes I read that and I go, no, it doesn't. You don't know that. You need to prove that, actually. So people are making claims.
Yeah.
Because it might work in that data set. You show it another one, like weird text or different language or fucking different domain of text, and it doesn't perform better at all. It might be worse. And so people make these wide claims about their algorithms they try to climb this ladder. We call it like the state-of-the-art ladder. And they're just trying to... Then Google comes along and goes like, oh, we trained this thing for 6 months in terabytes and terabytes of text. If you don't know how much a terabyte of text is...
It's gigantic.
Oh my fucking God. It's like we trained this for 6 months in our mega data centers with, fucking thousands of GPUs. Like, we burned the entire rainforest to train this thing in electrical power, the equivalent, to train this thing. And so our model can just, generate conversations, translate, do it better than you in your task. And people are like, okay, cool. I can't reproduce that, though. You made a huge model that memorizes all this shit. And there's no way to compare with it. There's no way to compete against it because you don't have the resources.
Yeah.
And so people are stuck in this hill climbing, trying to outperform everyone else in these tasks by 1%. And that doesn't advance the field at all. You don't know why you improved 1%. You just added a fucking layer to your model or a fucking component that jiggles the data a little bit differently, and suddenly the model improves 1%, and they're claiming, oh no, this understands human language. All this language also bothers me. This understands, or this model is natural language understanding. No, it's not. It's just a fucking thing that jiggles data a little bit and gives you better results than the other jabroni, and memorizes things, but and cranks out outputs that you understand, not the model. I mean, it does, but not in a human way, right?
Yeah.
And so we are stuck in this monorail dictated by big companies that you need to do things this way. You need to do things that result in models that are applicable to our products almost. We can use this model in the fucking search engine, so this is the way to do science. We can use this model to do automatic translations for Google Translate, so this is good science. And everyone else is following these footsteps, especially young scientists. And so we're adding to this fucking convergence of just people doing the same thing and hyping the shit out of each other. Yeah, holy shit, this guy just revolutionary AI can just make conversations with... No, it's just the same language model, but they have billions of... they trained it during months and with giant pieces of giant data sets and stuff. It's just the same thing. But it's like we are not doing. We're looking at the same thing instead of trying to figure out different ways to go about creating intelligent systems.
Yeah. All right. Let's get to the viewer questions. Is there any general or specific thing that drives the desire to mimic the brain?
What was it? Can you repeat that?
Is there any general or specific thing that drives the desire to mimic the brain?
Yes, we think we are special. That's it. That's really it. People think we are the pinnacle of people. Humans really think very highly of themselves.
Yeah.
And I mean, it seems like a joke, but it's really what motivates people. That they want a digital friend. They just want to create themselves, and have a copy of little human. Little homunculus because they think we're so fantastic. It's really is what it is, and like we are astonished at our capabilities, and so that's why people are trying to understand it. Like, we don't really know how brain works, and we thought that we could do it by scanning the brain, like every single part of it, and just reconstructing it. And so we would look at this fucking complete picture, and we could replicate it. Here's the thing. Humans are not just the brain. The fucking entire thing, that's what I was talking about. Your stomach has neurons, right? People don't know this, but you have neurons all over. You have neurons everywhere. And your entire thing is what composes a human, like the human framework and how we think, how we act, how we behave. But people still think that they can, humans are very good, and we want to imitate that. We understand that because it's so fascinating. The brain is a fascinating thing. How we learn things. How the fuck do we learn things? We know parts of it, but we don't really know. We want to replicate it. So there's this thing called the Human Brain Project or something like that, where they try to map the brain. And like we did it. It kind of failed, but we partially did it. And at the end we look at it and we're like, we still don't know how this works.
Yeah.
We might know every little component. We still don't know how it works. Because there's a difference between knowing the components and knowing how a complex in a mathematical sense of the word, complex system works. Because you might know every single part of it, but when everything interacts with each other, every component interacts with each other, you don't know what the end result is. Happened with DNA as well. People map the human genome. We don't know how it works. We know parts of it. We don't. There's so many little components interacting with each other that we don't know how the whole thing works. We just don't. It's not enough. But we're trying, though. We still think we're very special.
All right. I think that's a great answer. Like, in short, we think we're special, so we're trying to replicate.
Yeah, it is. But I think it's what it is. Yeah.
This is not really an AI question, but I'll take it anyways because I think it's entertaining. But you could become a cyborg and exchange body parts to become a better human someday. Is that something that you would take into account?
There's this. Myself, I'm already full cyborg. How can you tell? How can you tell? But I'll tell you this. There's this interesting thought experiment about consciousness. We don't really know what consciousness is, but people think it's a problem. I don't think it's a problem at all. But people really think it's this big mystery. But and so they're like they made this this argument against consciousness being just a matter of computation. And the argument is as follows. It's the Chinese room argument, right? Where you have a room, and inside you have a jabroni that doesn't speak Chinese, but has just a list of rules. But this was back in the time where AI was just symbolic and logic-based. They have a list of rules, but let's imagine it's a program that knows how to convert symbols from Chinese into English, and vice versa. And so a guy comes along and inputs a script in Chinese, and the person inside would look at it. They don't know Chinese, right? They look at it and they just apply the rules and return the text in English. And the people that know English outside the room will go, okay, this is the correct answer. And the thing is, because the guy that's operating the thing doesn't know Chinese, the argument is that a computer does not have intentionality. A computer is not conscious, because you can have a person that does not know what the fuck is going on, just using rules back and forth, and the system still produces the correct answers. But the system itself, the person doesn't know Chinese. The person is not doing it intentionally. And there's a couple of counter arguments. And one of them is, if you have a neural degenerative disease, start losing neurons, right?
Yeah.
And you replace them with machines, tiny machines that act just as your neurons do.
Yeah.
Just it's designed specifically to imitate each neuron you lose.
Yeah.
And so it's a machine. It does computations. It gets inputs and does outputs. You start replacing neurons. Your neurons die. You start replacing them. At which point do you stop being conscious? By the same argument, right? It's like the boat. If a boat is falling off and you start replacing parts of the hull, parts of the engine, parts of the thing, at which point does the boat stop being the same boat?
In the end, it's a philosophical questions, I guess. Like, I mean, I guess with a human, you could at some point find out.
I mean, no, you can't. That's
fails?
The point. The point is you can't, because you don't know what it is. And in the end, you could use the same argument to argue that a person is not conscious. Like, the same kind of thing.
Yeah.
But yeah, if you replace every single part of it, this is something for chat to think about.
Yeah.
If you replace every single part of your body, every single cell, slowly but steadily over time, at which point do you stop being you?
Yeah. The old Deus Ex game question, which I always loved about it.
Yeah.
Like, how many parts can you replace to stop being yourself?
Yeah. It's an interesting question. There's different answers to it, but like I think would I replace parts of me? I mean, I don't know. If they work properly, why not? If I need to replace something broken, I would.
Certainly, me too. Like, given we are at a point where we know that shit works, right? And we don't have to take like some kind of weird contract where the government owns our body if we can't pay for a month or something.
Yeah.
Like, just say we buy like a mechanical arm for like $5,000 and it's ours after, I'm down.
Yeah.
Like, not to replace a healthy one, but at least to replace a dead one.
Yeah, to replace parts. And that's another interesting application, actually. Yeah. It's interesting that we're talking about that, because people use machine learning models and stuff like that combined with the prosthetics and robotics to create this prosthetics that can actually interpret your nerves and stuff, your signals from your nerves, and just or your thought patterns when you think about squeezing something, and just your hand, your robotic hand closes and opens. Very simple stuff, but it works, and it's a life changer for many people that lost a limb or something.
Germany is actually really high in the research of that. Like, they do it in 15 different universities in Austria too. Like the psychological part of it. Because like the psychological question when you try to replace limbs, at what point happens inhibition? Like, if you think about raising your arm, you're not raising your arm, right? So at what point does that stop? Does it stop in the brain? Does it stop in the arm? So they're trying to find that out. Exactly. So that's what they're trying out. It's super boring to research it, but the question is super interesting. Because the way you research is you ask a million people to like think about raising their arm and you measure stuff and so yeah, it's not really interesting to research, but it's a super interesting question.
But I mean, most research is, people think like AI and stuff like that and robotics is super fucking exciting. So try researching it. You don't know. You don't know. It's boring beyond belief. The outcomes are very satisfying sometimes.
Yeah.
But doing it, oh my god. Oh my god.
Understandable. In the book Blueprint of a Soul, Dietrich Dörner claimed he already built a machine with a soul. Are you familiar with that? Ever heard that?
No, but I'm familiar, for instance, with the Google engineer that said that this language model was conscious, and I think he's an idiot. But and here's why: you don't even know what constitutes like consciousness. We can't put it. We can't articulate it.
Yeah.
Because I think that if you build an exact replica, a computational replica of a human, you could say that you have no counter argument to that being conscious.
Yeah.
Like some people would say, oh, it's not the real thing. That's not the point. It's a system that acts exactly how a human would. The brain has the same states. We compute let's imagine it is possible to compute every single state of every single fucking atom in your body.
Yeah.
To replicate a copy like you could take Deevoz and make Deevoz 2.0, put it in a digital box, and it's a full simulation of Deevoz.
Yeah.
There's no way you can say that's not conscious, because to me, consciousness is about the process of dealing with the environment and how you do it. But people would say, yeah, but that's, it doesn't have the same carbon substrate, But at which point, what convinces though?
Yeah.
If you have a human, you have a human. That's a tautology, right?
Yeah. True.
But yeah, so I think it's needed for many reasons. One of them is that we don't know what consciousness is. Even if we did, we would need a replica of a human to create a human-like consciousness. If we're talking about consciousness in general, I mean, you can make an argument for it, I guess. It depends on your definition, right? I'm writing a paper where I'll make an argument for machines being capable of understanding and knowing things, but I also make it very clear that they do so not in a human way. If you want a human way of understanding language, you need a human.
Yeah.
The machine understands things and creates meaning for itself and acts as if it understands things, but in a very limited context, in a very special case. Like these language models, it's like having a human that can't see, can't touch, can't hear. It's like mute, deaf, and fucking all the things. It just receives words telepathically, and his only goal in life is to predict what comes next.
Yeah.
This is a language model. Does it understand language? It might, in the context of predicting. That's it.
Yeah. There was a question that I don't understand, but maybe you do. Could there be an AI which erases all black swans?
No.
Okay. Then we skip it.
But black swans are, if you're talking about the financial markets phenomena, it's when you have a complex system, again, in the mathematical sense of it, where a market is very simple. You have transactions and people act on it, and if you act on it based on what you think is going to happen, that future will no longer happen because you interfered with it. This is what we call a chaotic system as well.
Okay, yeah.
And black swans are happen in microtransactions. Yeah. So high frequency trading. People start buying and selling super fast and at fractions, and they make a lot of money if their machine is fast enough. But sometimes, because of this interference of all the machines interacting with each other, you get a black swan, which is when the market just crashes beyond belief. Mm-hmm. But and then goes back up really quickly. Yeah. These are called black swans. If that's what the chat is talking about. Is there an algorithm capable of overcoming this? No, because you cannot predict the outcome of a complex or chaotic system. You cannot. It's impossible. It's mathematically impossible. Okay. There's classes of things in the world that are unpredictable, mathematically and absolutely.
Okay. What about the AI painting application? Is that also ripping off things? I think we partly already talked about that. Because, as you said, if the AI is taking works of artists that didn't agree to have their works in that, then it's ripping off.
Yeah, and you might say that, it's creating something different. But it's like if you ask a person that is really good at faking someone else's painting, and it just copies your paintings and sells them for a lot of money, would you think that's okay? No. And you think, he had something new, It had something new to my art, to this art. It's just copying your shit. That's what it's doing. And it happens it happened with another domain now, which is code. Like the people from GitHub just took the entire fucking repository of code, with or without permission from creators. Like I have code there as well. They trained a language model for code, I guess, in the entirety of the thing. And it's funny because the model outputs code, which is basically a copy-paste of someone else's code without the license. So, I mean, one could argue that there's so much one can do new in terms of code, but that's not true at all. I mean, if you have something with a license that you must respect, you must include the same license, credit the people that created it, even though the license is, you can freely use the code and modify it and stuff. You need to respect the license. And the same is happening. People train these models, they make these autocomplete models that generate code, and they just wash away the licenses. And that's not okay.
Mm-hmm. Understandable.
Same with paintings.
All right, perfect. I guess one more question, then we call it a day. What do you think are the jobs that are endangered the most by AI?
Jobs that are endangered the most by AI? Oh my god, I hope there's many of them. I really hope we can maximize the number of jobs that are endangered by AI. And because here's the thing. But I also think that needs to be coupled with different way of organizing society, right?
Yeah.
It has to do with here comes the socialist talk and shit. Like it has to do with means of production and stuff. Because imagine a current state of society where you have this huge inequality, right? And everyone has all the money and all the resources, and the other people just work for them. And if they have the means to automate most menial jobs, we really should. I don't think humans should look forward to just toil away and justify their existence by toiling away at Amazon delivery systems and stuff like that. And we shouldn't be aiming for that. That should not be the goal of humanity. So if we can automate that, we should. But here's the thing: these companies that now just automatically make money without labor, without anything. So inequality gets bigger. Whoever owns the means of production doesn't need people at this point if all the jobs are automated, and so it's just a money printing machine basically. And you might argue, but people can be specialists, and designing these teams. Not everyone, and very few people can do that.
Yeah.
Just like not everyone needs to know AI and machine learning and stuff. Not everyone does. It's a very niche thing. It's a very and what about everyone else? They are not entitled to exist, to live their lives, just because there are not things. Imagine a world where everything is automated. Most of menial jobs are automated.
Yeah.
Like food distribution, fucking everything.
Yeah.
You have physicians and scientists.
Yeah, roughly.
What about the rest of the people that don't want to do that? You can
say there's always social care, but you cannot put everyone into social care.
Yeah, it's
aside from the fact that a lot of people just don't want to do social care because it's kind of a you need to be born for that or built for that.
Yeah, but I think we need to rethink as this happens. We need to rethink the way we organize ourselves as society. Yeah, of course, there's a backlash. Like people with a lot of money don't want that, but we need to. There's no choice. Otherwise, there's two dudes that are rich, and the rest of us just fucking starve in the ditch somewhere. And while we go towards this slow descent into burning the rest of the planet down, it's but yeah, things that would be automated. I guess driving would be one of them. But again, we would get really good at it if there weren't other humans driving as well. Some humans are not very good drivers, so that creates difficult environments for the machines to be driving safely as well. Not just that one random dude just cuts you off out of nowhere that creates accidents. It's not a machine that would prevent that from happening. So most of the things that can be automated should, in my opinion. And there's a lot of them we could enumerate. You can ask me specific ones if I think this could be automated, but
fair enough.
I think they should, but we need change as well. That's my answer.
Yeah. I get this is after all a very interesting question, because for many people what they do for work is basically a good part of their life and their self idea, right?
Yeah.
Basically the idea of
you are what you do.
I am what I'm doing, exactly.
Yeah.
So if it's a job that can be replaced, we need a fast new solution for these people. Because not only are we taking away the jobs with an automation, we're also taking away basically what their self-perception.
Their sense of self. There's
Exactly.
their identity.
Yeah, right.
Because people identify with the things they do. But like, do people really identify with being an Amazon driver? I mean,
I can't imagine, honestly. I mean, I don't know. Have you played Death Stranding?
I have, yes.
So yeah, I mean, in the end, that kind of is partly it, right? It's more than just sitting in a car and delivering packages. You can also like view that and maybe really enjoy that.
That's why we need universal basic income kind of thing.
Yeah.
Paired with this, because otherwise, like, you need to give the people the choice to do the things they enjoy and to discover those things as well. But at the same time, if they enjoy just, you know, carrying shit from one place to another, that's fine. But their entire existence and their entire idea of self should not depend on that. Okay. You should not be, your entirety of your being should not be tied to a menial job. If you enjoy doing it, just do it. But don't think that you are it's a box carrier. You know, there's nothing wrong with that, but it creates problems, right?
All right. So to wrap this up, where can people find what you do in the internet, what you are about? That's your self-promotion spot.
What is it? I'm self-promoting now?
Yeah, do it.
Shit, guys, go watch my stream as well. I never talk about this stuff. It's great. It's great. It's great. But I don't know. I don't want to push my scientific stuff because no one reads papers anyway. So, but if you look up David Nunes, you know, you should find it. But also go to my stream and just you know, we play a lot of Hunt Showdown, and Euro Truck Simulator. It's great. Fucking card games. We make a lot of jokes. We talk about humans being, you know, just pieces of shit all the time. Yeah, just okay, just barely good enough. It's fine. It's fine. It's a safe place to shit on other humans. With TLC, with tender love and care. Teriako. That's my. I don't have anything to plug. Just go watch the stream. It's fine. It's just okay as well. It's just barely okay.
Barely okay, perfect. I'll put all the links in the info box of the podcast. Thank you so much for listening, for watching if you see this on YouTube. If you have an interesting topic, a field that you are very, I don't know, informed on, that you want to talk about with me, send me like a DM on Discord, or I don't know, fuck it, send me an email. That's okay. Can also send me a letter, but if you find my address anywhere.
A fax. Send Deevoz a fax.
Actually, that's the one thing I cannot receive. I don't have a thing to receive fax anymore. Can send me an SMS though, or I don't know if you find it a bird. Anyways, thank you guys for listening, and yeah, see you next time.